Okay, problem number 17 is straightforward. Section D, we're dealing with tangent lines and linear approximation. Right now, we're just dealing with a straightforward skill. We're talking about finding the derivative of a function and evaluating that function at a specific location. So the first part of this problem is to differentiate f of x. We're going to rewrite this as f of x equals the sine of 4x quantity cubed. Recognizing now that this is a composite function, we're going to use the chain rule. The derivative of, well, let's see, the outside function is something cubed. The derivative of something cubed is 3 times something squared. The inside function doesn't change. Now we need to multiply by the derivative of the inside. Recognizing that this is in itself a composite function, we're going to have to use the chain rule again. The outside function is sine of something. Derivative of sine of something is cosine of something. The inside of 4x doesn't change. Now we need to multiply by the derivative of the inside times 4. So if you clean this up a little bit, we'll get 3 times 4, which is 12, times the sine of 4x quantity squared times the cosine of 4x. Now let's see, they want us to evaluate this at pi over 3. Let's see what this is going to look like. 12 times the sine of 4 pi over 3 quantity squared times the cosine of 4 pi over 3. So think about it. There's a bunch of ways you could approach this problem. If you remember that pi over 3 radians is 60 degrees, then you know that 4 times pi over 3 radians equals 60 degrees times 4, which is really 240 degrees. So let's see how that would help us. Let's sketch a unit circle. All right, so we always start measuring from the positive side of the x-axis, unless otherwise stated, and 240 degrees. So we're going to go past 90, past 180, but come up just short of 270. So we'll be down here somewhere. And let's see, we went 60 degrees past 180, and we're going to 240. So it's kind of cramped. Let me pull that circle out here, or excuse me, that triangle out here. We have a right angle, 60-degree angle, and this guy down here must be 30. Again, there's a bunch of ways you could go from here. You know, in a unit circle, the hypotenuse or the radius is always 1. In a 30, 60, 90 triangle, the side opposite the 30-degree angle is always half the hypotenuse. That's the short leg. And the side opposite the 60-degree angle is the long leg. That's always the short leg times root 3. 1/2 times root 3 is root 3 over 2. However, remember, we're down here in the third quadrant. From the origin, we went to the left, so we have a negative x value. The length is positive, but the direction is negative. And we went down, giving us a negative y value. Okay, so the coordinates of the point down here, where this terminal side of our angle intersects the unit circle, this is at the point negative 1/2, comma, negative root 3 over 2. Now let's substitute and see what we can do. Remember that the sine of an angle corresponds to the y coordinate. Remember, xy is in alphabetical order, so is cosine theta, sine theta. Sine corresponds to y values. So back here in our derivative, we're going to have 12 times the sine of 4 pi over 3, which was the y value, negative root 3 over 2, quantity squared, times the cosine of 4 pi over 3. Well, cosine, that corresponds to the x-coordinates, times negative 1/2. Now let's just go from here. Negative 1/2 times 12 is negative 6. See, we did this guy times that guy. And negative root 3 over 2 is squared. Well, negative times negative is positive. Root 3 squared is 3. 2 squared is 4. So negative 6 times 3 is negative 18/4, which can reduce to negative 9/2. Whew, that took some work, but what a great review of our derivative and trig skills. Negative 9/2 matches with option letter B. Now that problem was no joke. Straightforward, but a bunch of little steps to do. Thanks for watching this video. Hopefully you enjoyed it and found it helpful.